So in our next video here, we are now going to be looking at the similarity of polygons. Similar polygons are the ones that are in the same proportion, so it's the same type of shape. If you were to cut them out on pieces of paper and hold them in front of a light, put the smaller one closer to the light source than the bigger one, they would cast identical shadows. So all those proportions are exactly the same, but the scale isn't. So one might have sides of 3, 4, 5. Another might be a triangle with sides 6, 8, 10. So identical angles inside our shapes, but not identical side lengths. All the side lengths are different by a factor. So let's take this example. Just put together a quick polygon here. In this case, it's a triangle. So we can create a similar shape by saying this is the shape we want to dilate. We want to dilate around, say, point A here, and we want to make it twice as big. So a scale factor of 2. The angle at angle A is exactly the same as are in both triangles because it is really the same angle. We can even measure that directly. So for example, if we measured this angle here, the way we've drawn it, it's a 54.4 degree angle. These angles would also be the same. So we plot our 3 points here. That is a 75.1 degree angle. And so is that. Angle ACB is a 50.5 degree angle. There is a 0.5 buried under that symbol, just there is a 50.5 buried here. So the angles are identical with these similar triangles. This will always be the case when we are dealing with these factors. So if we do another scale factor, we can highlight everything and give it a scale of 0.5 from there. We've created 2 other similar polygons. So these are each half the size of the other. We can measure all the angles. They will be identical angles. So we can scale them however we want and from anywhere we want. We can put our point out here as our reference and build our scales and our dilations, and all of these will come out from there. A scale factor of 1.2 doesn't change it much. It just adds 20% of the distance from D to that point as measured the shortest way. So if we were to connect lines between D and any point before it's scaled, that goes through the same or the corresponding point after it's been scaled. And that'll be true with every one of these scale factors. We pick one and we can see which point it's been scaled to because they will all go through the same point. I apologize, I just accidentally changed the size of our shape here. But those scale factors are preserved. So we can take these points that had some flexibility, move them around, and however we build it, they are all going to be following straight lines from that point from which they are being scaled. And those angles will be preserved all the way through. So 47.5 and a 47.5, 80.5 and an 80.5. And again, the 52s are actually in exactly the same place because that's where we scaled it from. So these are all similar polygons. They are all positioned relative to each other in these shapes. So those are really the keys to the similar polygons. We can get rid of our angles here as well, since we are losing all of our scale shapes. I may have deleted a bit too much though. But that's the idea between similar polygons. The angles that you measure for one are going to be comparable to the angles that you measure for another. They don't necessarily need to be clearly lined up. You can build these 4 vertices regular polygons. These are similar. And to show that, you have to show that all the angles are the same. In this case, they're squares, so it's not super challenging. Might be a little more challenging with a heptagon, but it is still quite possible. You just have to find your scale factors. So you would have to measure, say, the distance between 2 points here and the distance between corresponding points there, and we would get our scale. Similarly, the distance between these two is 1.8 units. Distance between these two is 4.2 units. So we can take the ratios of those and have identical ratios in any such case. And this ratio that we see here, that's an 8/5 ratio. If we look at this area, it's an 8.6. This one is a 21.4. Now, aside from the round off error that occurs because these are all chopped off at the tenths place, I believe we can even increase that with the number of decimal places that will be displayed. I'm pretty sure I saw that option on here somewhere. Don't remember exactly where. But you can increase the number of decimal places and get more precise ratios. Now this ratio 8/5 is not consistent with the areas because those are areas. You have to take 8/5 squared. And 8.6 times 8/5 squared will match 21.4 up to round off error. But these are all our scaled polygons, and these are our similar polygons. So again, similar polygons are polygons where all the angles are the same, the lengths are not, but the lengths differ by a consistent or uniform scale factor.